Hello everyone, today I will present my project in artificial intelligence course, which is about a neural network and genetic algorithm for a self-driving car. Background: creating a self-driving car simulation using a genetic algorithm approach. The goal is to develop a system where cars can navigate, track autonomously by learning from their experience and improving their performance over time. Here we will go with the basic definition and how it's works. Neural network controller. Controller takes inputs such as car position, velocity, orientation, and output control signals to steer the car. Genetic algorithm evolved the population of a neural network controller over multiple generations, improve the performance of the cars. Fitness evaluation. The fitness of each car is evaluated based on its performance in the simulation, how far the car can travel, how quickly it completes the track, or how well it avoids obstacles. Selection. Ensure that the best performing individual have a higher chance of passing on their genes to the future generation. Crossover. Pairs of selected individual exchange genetic information. Mutation. It's introduce random changes to the genetic material of individual. So we will go. You will see the simulation that I create. As we can see, here is the car. The manager, which has the initial population, which is 85. We will select at each generation the best agent, which are 8, and the worst agent, which is 3. The best agent we will try to pass it to the next generation, and the worst we will drop it. Number to crossover is 39, and okay, so I will run the app, the simulation I mean. As we can see here, the current genome is increasing. Each time the car hit, the genome will be increased. So until it's reached 85, the next generation is started, and the next generation will be with the best 8 agent that we will pass them to the next generation. As we can see here, we are in generation 1. So if we as we can see here, the fitness overall, it change every time. There is a limit. If it is reached the limit, it will reset. We can increase the speed so we can see the result faster. So now, as we can see, the car is performed better from the previous, from the first generation. Now we are in generation 4, so the car is performing much better. Okay, so I will explain the code. So genetic first here, car controller. As we can see here, so I will explain the code. We have 2 header layer, and each header layer have 10 neurons. We have 3 input, which are sensor 1, sensor A, B, and C, and here our neural network, as we say before, we have 3 input, and we have 2 output. We have 2 header layer, the fitness. So our output, we have 2 output, one for acceleration, the other is for steering. We use for acceleration segment because it's bound from 0 to 1, and we use for steering time because it's from -1 to 1, so the car can turn left or turn right. And the genetic algorithm, we have the initial population, which is 85, to control the genetic algorithm. Current genome, which is to track the genetic algorithm, it's good or bad. We will select at each generation the best 8, and we will try to pass them to the next generation, and the worst we will try to drop them. The number of crossover, it's a number of crossovers aim to combine the best feature or characters from the parent to produce generation with improved qualities. And that's all. Thank you for listening.